Welcome to the MS Dev Show, episode number 186. This week we talk with Rita Zhang about Docker and Kubernetes. Visual Studio Code gets log points. And the file manager from Windows 3.1 is finally open source and accepting pull requests.
Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications. Check it out today at raygun.com.
This week we have Rita Zhang, software developer at Microsoft, doing lots of work with Kubernetes and Docker. How's it going, Rita?
I'm good. How are you?
Good. Carl, what's going on?
First, I'd like to remind everybody to sign up for our Slack channel at slack.msdevshow.com, and that will get you into all the chatty goodness that we're having on at msdevshow.slack.com.
Absolutely.
Also, I don't think we've officially mentioned this, but we will both be at Build this year. So that's May 7th through the 9th. We will be recording podcasts. And I just picked up some awesome new swag today. And maybe one or two of you guys out there, come find me. And we will have a limited number of new swag to hand out. Yeah. We're going to leave that be a surprise. It's pretty awesome.
Yeah, super expensive. That's why it's like super limited. So you gotta be like a super fan to get one of these. So okay, so what do we have for the comment of the week?
Ahmad Awais reached out to us on Twitter. He said he's a big fan of the show and keep it coming. And also, I hope it's not too far out there if I told you that your show inspired me to build this. And it's a WordPress AI project that he's been working on. And you know, on WordPress, when you hit the add new media button, you kind of go through that dialogue and you can add stuff. Well, when you add new media, his extension automatically goes to Azure, looks at the media that you're attaching, and auto fills in the alt attributes for it, awesome, for accessibility. That's great. And he's got a YouTube video out there. We're going to get that in the show notes because this is a YouTube video. It's pretty cool. And he said it's not done, so he's going to let us know when it is done. Okay. And we'll definitely bring it up again. Yeah. But I saw this and I was like, holy cow, this is amazing. So we had a little bit of back and forth on Twitter about this, and I just thought it was an awesome project. Yeah, that's pretty cool. Yeah, and it's definitely solving like a problem. It's automating and making easier, and that's something that both of us like.
Yeah, even if it's small, right? Like, I think people think that they have to build these giant applications, but even just writing like a couple lines of code to just do like one small thing, like if everybody was doing that all the time, the world would be so much better.
Yeah. So if you want to get mentioned on the show like Ahmad, send an email to feedback@msdevshow.com, comment on Facebook, YouTube, or Stitcher. And we also really like those 5-star iTunes reviews.
And you told me we're somewhere else now.
Yeah, we are now on Spotify.
Woohoo! I don't know who uses Spotify for podcasts, but I'm sure they're out there.
One of the cool things about Spotify, it means that you can also ask Alexa on Spotify, and you can just say, play the latest MS Dev Show.
Okay.
Boom.
Well, that sounds cool. I have still not entered that space. I don't have any assistants that I can talk to. It's just me and my kids. Okay, so let's jump into the news. So the first thing we have here, which I thought was kind of interesting, was the Windows file manager from Windows 3.1. All the source code's out on GitHub.
Yeah, I think it's interesting, not just how much like modern stuff that Microsoft is putting on open source, but like some of the old stuff that they're just happen to clearing out. I've seen people on YouTube actually get this up and running, and it works. One of the questions I had, I'm not sure about the answer to this, is does it support some of the new Windows features like long file paths? Because I know that's something you kind of have to opt into.
I love that there's like a whole bunch of pull requests.
Is there?
Yeah. Well, there's 27 closed and there's 6 open. Let me look at the closed ones. Were any of them merged?
I don't know, but like some of the code comments are kind of interesting. I'll have a link to one in the show notes. It says, I shouldn't have to save this, but I don't trust anybody.
Yeah.
So he's got like access. I think it's to like a Windows handle or something.
There is like significant conversation on some of these pull requests. Include some fixes, lots of good suggestions. You please break them down into specific fixes. Talking about the commits, talk merge tool. Let's see here, man. And then there's questions about like some of the code and how it works. I was trying to see one though, if there was one that was, merged and like, what is the point? Oh yeah. Look at that merged right there into master. So let's see what they added. They added bash shell support and, they modified the way to check the bash path. So it adds a start bash shell to menu, which opens bash on Windows if it's installed. So they are literally modernizing the old school file explorer.
That's pretty cool.
That is pretty cool. Wow. So yeah, I mean, it's interesting. So we have the original code base preserved, and then this thing's going to like mutate into its own thing, I guess. That's pretty cool. Were you going to mention some of the comments in there?
I did when you were talking about the other stuff.
Okay, I was totally not listening like usual. Okay, so let's move on to the Visual Studio roadmap.
Yeah, there's a blog post that outlines what essentially for the rest of the year, what's on the roadmap for Visual Studio. And there's some stuff, pretty cool things on there, like F5 to run applications in Kubernetes.
Ooh, that's relevant.
That's pretty relevant to today.
Did you know that was on the roadmap, Rita?
Yeah, I saw a demo of it like
cool.
couple like few weeks ago, I guess, by the developer who did the whole thing.
Okay, very cool, very cool. What else, Carl?
Also, adding the step back feature of IntelliTrace for .NET Core, that's going to be coming out in the first half, I believe. Adding integration directly for Azure Key Vault into your C# apps. And one that I am really interested in is adding multi-editing, which is multiple cursors and selection support. So you can, I use this all the time for Markdown when I'm doing a lot of bulk editing, get multiple cursors on the screen for things that you want to just bust out repeatedly.
I didn't realize that wasn't in Visual Studio because that's been in VS Code for a while.
Yes, it's part of VS Code, but it looks like it's now coming to Visual Studio.
Very cool. So they're both getting better. I bet you there's lots of cross-pollination there, so that's great to see.
Yeah, and check out the link in the show notes because there's like, I don't know, 60 or 100 things that's on that roadmap. So find one that's interesting to you.
Yeah. Very cool. Okay. The Stack Overflow Age Part 1.
Yeah. Joel Spolsky was one of the founders of Stack Overflow. And now that Stack Overflow is over 10 years old, I know it's hard to believe, right?
Yeah. It's over 10 years old. Oh my God.
Yes.
Next, you'll be telling me Jurassic Park came out more than 10 years ago.
It did, Jason.
So is GitHub, I think.
Oh, really? Yeah. But that's crazy too. Yeah, that's crazy.
Also, a couple of days ago, that was the anniversary or whatever.
Oh, very cool. Very cool. Man.
Yes,
time
we're
just
getting
keeps
old.
going faster and faster.
Makes you feel old, right?
Well, yeah, because you could be. Look at this. 10 years ago, it was GitHub was founded. So that was when the company was founded. But I suppose they probably had some. Oh, yeah, launched April 10th, 2008, which was 10 years ago. This is crazy because they always say it takes like 10 years of working on something full time to be like an expert. So, I mean, you could now, there now exists GitHub and Stack Overflow experts. That's pretty wild.
Nice.
You still there, Carl?
Yep. So, yeah, this article, starts like going about from behind the scenes, like, how it got started and some of the details, in those early days. So if you're one of those people that are interested in kind of how it got started and some of the reasons why things happened, check it out. And it sounds like, because at the bottom, he says part 1, that there's going to be a few more articles to this series. So
yep.
I lived through this. I remember when it first came out, I definitely followed Jeff Atwood a lot. Mm-hmm. And I was one of the first people on there. And just seeing this is really cool to get some of that backstory.
Yeah. And I listened to their podcast and on the podcast, they went through a lot of this and they were making a lot of decisions on the podcast. So that was pretty cool. I don't think they make it anymore. Like they stopped. I don't know if they ever started back up again.
They did, but it's different. It's okay. With, it doesn't have either of them anymore. So it doesn't have Jeff or Joel. And it's, some of the execs there just kind of having fun more than anything else.
Yeah, the best part of it was just one of them saying something and then the other going on for 30 minutes why the other one was wrong. That was the whole fun of the podcast. I watched it for the drama.
So it's like most of our internal discussions?
No, not at all, Carl. You're totally wrong. And here's why. Here are 10 reasons why you're wrong. Okay, so next story here. Log points for Node.js and VS Code, a way to inject console.logs into your running app. This is so awesome. Like I haven't gotten a chance to like really use this yet, but this is great.
It was funny because before you were just like, I wonder how you do this. And you looked it up. You're like, oh my gosh.
Well, yeah, because what you do is where you add a breakpoint, you just right click on there. And then there's add breakpoint, add conditional breakpoint, and then there's add log point, which is the new one. I should give this a try. I haven't even tried. I mean, I've tried it like in VS Code, but I haven't actually like watched the logs and I'm going to give it a try right now.
As we speak.
Add log point. What should I say? Carl is amazing with like 15. You want 15 exclamations? Okay.
16.
Oh, that's cool. So you get a little, that's cool. So what you get is the breakpoint symbol, instead of being round, is actually a diamond, which great job using a shape and not a color. Thank you. And then whenever you hover over it, it says Carl is amazing and with a whole bunch of exclamations. So I like that it's still like fairly visible. So I will now start debugging, and it's right at the beginning of my code. Okay, debugger listening. Oh yeah, look at that. Carl is amazing. Very cool. What I haven't figured out yet is where it actually stores those breakpoints. I don't know if it's just like on your local machine, because I don't see anything in my checked in code that changed whatsoever, which was obviously the point, right? You don't want to change your checked in. You don't want to pollute your code with that. So that's one thing that I'll have to figure out, and then we'll have to mention that on the show. Anything else you want to mention on that, Carl?
Nope.
Okay. Let's see here. Last story, comparison of Azure IoT Hub and Azure Event Hubs. You want to talk about this one?
Yeah. So this is kind of related to another story that we're not going to talk about. There's a new tier of IoT Hub. So there was the IoT Hub standard tier, and then there's a basic tier that was added, which was essentially just telemetry and security. Mm-hmm. And what a lot of people don't know is, if you look at the documentation, it's littered all over the documentation that IoT hubs are Event Hub compatible or have Event Hub compatible endpoints. Well, spoiler alert, it's because IoT Hub is a bunch of event hubs that are stitched together behind a load balancer. Mm-hmm. Surprise, surprise, right? And well, because of that, here's a guide of when you would want to use an IoT hub versus an event hub, and also between the standard and the basic tiers. So if you're looking to understand the differences between those, here's a fairly short article, probably takes you about a minute or two to read, that just goes over like why you would want to use one over the other. And if you're looking to do any kind of IoT scenario, you really want the IoT hub mostly for the security.
Yes. So this is very cool. Any other comments on that? Or should we talk to Rita about some cool stuff? Man, it's just so much cool stuff in this episode. Okay, so Rita, I mean, the reason that we had you on here is because you do a lot of work around containers and Kubernetes, and we wanted to have kind of a combined episode where we talked about those things and how they actually work together. And it seems like the world is converging on those technologies, so we figured that this would be a great time to start actually talking about it. Plus, I've actually started using these things, I would say at the hobbyist level recently. So maybe where we should start, Rita, is, if you could give us like just a brief refresher on containers and kind of where we're at these days with containers.
Yeah, sure. I think, as you said, right, containers have evolved a lot the past, I would say, 5 years, where initially, most people were pretty confused, like, is it just a VM? Like, what is this, right? And as a lot of open source communities really got to work together, all the companies, I don't know if you guys have been kind of watching the CNCF community, and there are just way more companies now than there were like even a year ago. Mm-hmm. So lots of improvements, and the reason why people are more gravitating towards containers is because it allows developers an easy way to package up their solutions. Meanwhile, ensuring that you get the same experience in production without having to worry about, hey, but this works on my machine when I developed it, right? Meanwhile, for the operations folks, they don't have to then having to troubleshoot, why is this application not working? How do I make sure all the required resources are in place in this production server? And how do I make sure it's scalable when people are hitting this application hard?
Mm-hmm.
So, one thing that I get from a lot of people when I start talking about containers is people are like, is that Linux only? So since there's a lot of confusion on there, can you help clear that up?
Yeah, absolutely. No, it's not Linux only. There's definitely container runtime for Windows. So if you have a .NET application, let's say you want to run IIS, you could totally do that. But it would require an operating system that supports that container runtime.
Mm-hmm. And if I happen to have like a Linux container and I happen to run Windows, am I out of luck, or do those work together?
It depends. So obviously you wouldn't be able to run, like, say, IIS on a Linux machine. But again, depends on your OS distro. If the kernel actually supports running that particular runtime, then you should be able to.
Mm-hmm. Yeah, I think that's probably a good point of clarity, right? Because like the only thing that really matters is like the kernel. Other than the kernel, you're like packaging up everything that your application needs. So, sort of the only variable is this a Windows kernel? Is it a Linux kernel? And that's really just the distinction, right? I don't think are there any other flavors of containers? Maybe that's a good question.
Yeah, there are actually. You mean container runtime?
Yeah, container runtimes. Yeah.
Yeah. So as we all know, in the beginning, Linux had its own container runtime, and then Docker, the company, and a bunch of folks in the open source community added a lot of features to make Docker what it is today. Mm-hmm. But having said that, you guys probably seen the news about how Simon, the founder of Docker, just left Docker, and then there is container, which is basically another version of Docker, but a lot lighter.
Oh boy.
Yeah. So not to confuse you, but there are definitely other flavors, and then there's also folks who are working on the container interface, the open container interface, so that, orchestrators like Kubernetes or other orchestrators or platforms who rely heavily on containers, like, say, Cloud Foundry or like Mesos, right? Like those are the type of where they will rely heavily on the open container interface to make sure the orchestrators actually work across different containers.
Okay, so does Docker implement that open container interface then? I mean, could you, if you have something that supports the open container interface, can you run those Docker containers in that system?
Yeah, so the latest Docker, if you go check out the latest Docker, actually it does support like clear containers and containered. I'm not an expert on this, so like I'm only like kind of just observing at this point. But to your point, like, for example, Jesse Frizzell like actually added clear container support to ACS Engine, which is the backbone of AKS, Microsoft Azure's own flavor of Kubernetes as a service. So why do we do that? Is so that we can support, more than just Docker container runtime.
Yeah. Well, that's pretty cool. My only worry there, the reason that I was a little scared for a little bit, it's like, one of the strengths of Docker is like the support that's going around everywhere, and because we've all sort of rallied around the same standard. So it does scare me a little bit when it's like, oh, there's this new thing over here, and it's like, oh, is this going to be like the web frameworks where I have to like rewrite my code, every year to have the latest and greatest technology? But it sounds like that's not really the case, right?
Yeah, I mean that's why we want a common container runtime interface, so that the things that talk to it wouldn't necessarily, it will all be abstracted, right?
Okay.
But to your point, like there are things that makes Docker containers kind of big, and that's why we wanted like a lighter version of that. But as long as we all follow the same interface, it should at least be able to work with like seamlessly with all the orchestrators.
Okay, I'm okay with that. I'll allow it. So one question, and this is really like, I think kind of a newbie question. And I hope that everybody listening has a reasonable understanding of containers at this point, but like, do you want to speak to the, around, the speed and the performance of containers versus VMs and like what the difference is there?
Yeah, absolutely. I would say, for folks who are listening, I guess, like, have you ever started a VM, right? Like it usually takes minutes, just because you're actually, you're booting up the operating system, right? Whereas the reason why containers are actually much faster, we're talking about seconds and sub-seconds because, again, you're sharing the kernel. So the machine is already there. And all you're doing is I hate to use the word booting up, but like you're essentially running the images on top of the on top of the
you're just
kernel,
starting them, right?
And you're just adding the resources that you need,
right?
So you're not you don't have to worry about all the extra stuff that your operating system needs to worry about, and that's why it's a lot faster.
Yeah, and just to help our listeners, like there's probably people thinking like, why don't I just like copy my files over to this other system and run them? But I think it's, if you actually start to use containers, you really understand why. I mean, let's say you want to set up an Nginx server, like Nginx expects a configuration file in a certain location, and you'll put your web files in this one folder. And it's not that complicated, but you throw that into a Docker container and you literally do just that along with Nginx and all the binaries, everything's in that container. You start with that base image and now you can easily deploy that. Like I have a blog post on it. I mean, it's literally like a 3-line Docker configuration to get like an Nginx web server running in a container and being able to run that on any machine that can run Linux containers. So for me, I think that's when like the light bulb finally went on for me. Because you could make a script that's like 15 lines of code that's like install Nginx and then do this and do that, but it might not be the same Linux variant, or there's like a million reasons why we always do this thing where the classic developer excuse, works on my box. It works on my machine. Well, in a container, right, you're essentially shipping your machine minus the hardware and the kernel.
Yeah, so seeing that these are run so much faster and they're kind of similar in many ways, do we even need VMs anymore?
Yes, there are still cases. I mean, obviously, your monolithic like legacy applications, right? But then also, where do you run Kubernetes, or where do you run yes, you can run on bare metal, but still there's probably times where you don't want to do that. So I definitely see, of course, it's just a matter of when do you use this, and obviously containers are not going to handle all the legacy stuff. So
and VMs are a good level of isolation, right?
Yeah, absolutely.
Yeah. So, my question, I once I discovered Docker, that I was like, Docker all the things. And I actually went through and, I've almost, Dockerized every single thing that I have on GitHub that I've written. So like, should I be putting everything in a container these days?
It depends. I would say to your point, like if it's things that you can easily run on a Linux machine, you should be able to. Where it's a little challenging is usually things that require, like, say, device drivers, right? And that's where the container runtime actually you would need support there. So, for example, GPU support in Docker container is a collaboration between obviously like NVIDIA and Docker and the community, right? So until that's in place, that wouldn't work if that's a resource that we need, right?
Okay. Yeah, I didn't even think of that. That's a good point.
Yeah, and I think last time I checked, for example, there's like no GPU support on the Windows container today. So, yeah.
Okay.
So last time that I pulled down an image from Docker Hub, I noticed that it pulled down a bunch of different layers. What are these layers in a Docker image?
So I think we talked about, like, the reason why we liked it is because it's sort of like a recipe, right? Like where you say, okay, imagine you start with a blank Linux machine and run these scripts, and then you end up or install these binaries, and you end up with this environment that can be repeated over and over. And while that's great, that's one of the benefits. What the other benefit is also, you get to sort of save the output of that environment as another image, right? And the beauty of that is then you can use that image. Someone else can add stuff onto it, so that you don't have to rerun the same thing over and over.
And that's also good for deployment if I'm using the same images over and over again, because then if I don't have to re-download, like if I'm basing it upon like the ASP.NET Core image that is Microsoft puts out, after it downloads that for the first time, next time it only has to update the layer that has my code, right?
Yeah, exactly. And so say if you are on a machine and you have to run 100 different apps for different people, and let's say they're all Node.js applications, chances are they're all using the same baseline resources, right? Or binaries. So you all those dependencies would just live on the machine as that single image. And to your point, they wouldn't have to like be downloaded every time.
That actually brings up a good question then. So if I have 1,000 Node.js applications and I base them all in the same base image, like, am I adding a whole lot of overhead by containerizing the 1,000 applications, or is it going to be pretty close to if I was just running them on the machine itself?
Well, because you're sharing, right? I mean, your actual container, it would be isolated to your application, but the binary itself, that will be, again, the base layer is shared, right? Yeah. And that's just like stuff that your application needs, but not the it wouldn't be duplicated every time.
Right. So from a disk space perspective, I'm not going to be taking up a whole lot of disk space. What about like CPU and memory then?
That's dependent on what the resource is needed by the container itself at runtime.
Okay. Is it usually pretty good though? I mean, is there, do you generally see like a performance hit by containerizing an app?
It's no different from, say, running in a VM, but where it is a little different, and it's a benefit, is you get to say, I need this much memory, I need this much CPU, for example, and if it's not there, it wouldn't come up, right? Or it's in the Kubernetes world, it will actually be pending until that resource becomes available. The other benefit of it is also you can describe, here's the upper limit of the resource this application should take. So if something happens, it wouldn't crash your entire cluster.
Yeah. So now I think we're sort of getting into the world of orchestration, which I think probably a good segue into that is, if I have If I have an application that has multiple, I don't want to call them layers. I want to call them like multiple components. So I have one container that maybe is my Node.js application. And then I have another container that's Nginx, which will be proxying that application. So those two containers have a relationship. One should, be connecting to the other one, and then it should also get exposed out. So in general, like, what's the best way to like define that relationship between those containers?
So in Kubernetes world, let's use the example you have earlier, which is basically service discovery, right? So everything inside of Kubernetes will be able to discover as long as you're in you have the permission to discover it, to talk to it. But in say in Nginx example, you'll be able to say, okay, for ingress of this application, and now all the traffic has to go through the Nginx pod, right?
Okay.
And you're telling Kubernetes to use the Nginx pod as the ingress controller, and then you have to tell the ingress controller, hey, for this particular resource, now, like if I'm getting traffic for this particular resource, now go route to this particular application or resources in the cluster. So in this case, if you have like an application running on /foo or whatever, right? Mm-hmm. When traffic comes in, then Nginx controller says, hey, that should map to the full pod, and it's going to actually, the full service, and which is running in the cluster with its own cluster IP, and then it's going to route the traffic to that particular service, which is all actually internal, right? But to the external world, people won't see that detail.
Right. So how does Nginx know? Like it has to talk to the backend Node.js service. Like, how does it know? Is it hard coded to like an internal IP, or how do I configure that?
Yeah, so there's actually a whole lot of resources on Ingress controller. There are many types of Ingress controllers, but a lot of people start with Nginx. So the way it works is that you have to tell the Ingress controller based on the path, like which service to map to, and Kubernetes will be able to discover based on the mapping which service to hit. And each service, actually, when you run it in the cluster, it will have its own private IP. So 10 dot whatever, right?
Yeah.
So think of it kind of like a routing table of some sort. So when you hit the Ingress controller's public IP, right? It will actually off of that path, 40 dot blah 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 /full. It will actually be internally mapped to the full service at 10 dot blah blah blah.
Okay, and then do I get on the Nginx container itself? I mean, am I just hard coding that against like an internal host name then, or an internal IP?
It's not. There's all kinds of Kubernetes resources, and in this case, is the Ingress resource. So you will have to be able to tell it to like this path. Off of this path, look for this service. Yeah.
Okay, I gotcha.
So everything's service discovery.
I gotcha. Yep. So I'll use service discovery internally. I gotcha. Okay. That makes sense.
Raygun provides full stack error, crash, and performance monitoring for tech teams. Whether you're a software engineer looking to diagnose and resolve issues with greater speed and accuracy, a product manager drowning in bug reports, or you're just concerned you're losing customers to poor quality online experiences, Raygun can provide you with the answers. Get full stack error and performance monitoring in one place. The next time you're struggling to replicate errors and performance issues in your codebase, think Raygun. Head over to raygun.com. Get up and running within minutes and dramatically improve the online experiences of your users. You had mentioned Kubernetes. What is Kubernetes and how does it fit into this container world?
So Kubernetes is one of a few options for actually orchestrating containers. So when you're in development, like on your laptop or whatever, you create the Docker image and you run the image as a container. But that's just a container that runs on its own, right? But when you're in a large organization and let's say you have an application that has many, many components to it, it's actually perfect for an application built off of like microservice architecture, such that your applications will be able to discover each other, and each component, each microservice will run as its own container, right? And so in that case, you would need something like Kubernetes to orchestrate, when do you run which container, where do you run it, how do they discover each other, how do you make sure that external applications can talk to it, how much resources allocated for each container, how many instances of this container do you run, and what happens when, say, I don't know, the service that handles the data load, it gets hit really hard. How do you scale it up, and when do you scale it down, right? Mm-hmm. So that type of thing. So that's I'm really simplifying it, but that's like the essence of like why you would need an orchestrator. And to your point, like again, running a container on your laptop is like one thing, but like be able to decide where to run the container in the cluster depending on the load. So whether that's because of your resource constraints, right, or the need of your resources. So say if you running a pod or a container that requires a GPU, you probably want to run on a machine that has a GPU, right? Mm-hmm. So similarly, with if you have a cluster with Linux nodes and Windows node, if you have to schedule a container that requires Windows container runtime, then you have to make sure you run it on the Windows node, right?
Yeah, well, that's pretty cool that you can do that. I think that's a pretty neat feature. And then as far as like the maturity of Kubernetes overall, I mean, it seems like it's been out for a while. It seems like it should be getting pretty mature now. Is like now the time to start learning it? I guess the answer for you was you started learning a long time ago, but for the rest of us mortals, like is now the time to start learning it? Would you wait? What is your feedback on that?
I definitely say don't wait. I love this stuff, and I think I feel like this is basically we're past the point where people are asking the skeptical questions already. Like we're already past that point where people are asking, oh, can I really do this in production, right? And because we're seeing people running this stuff in production, and we are basically we're transitioning from like, oh, everyone just like sort of playing with this thing to like, oh, I'm here, I'm going into production with this stuff, and here are the production level requirements I need. So we're transitioning to that stage, and because of that, to your point, there's a lot of features, exciting features that are coming to Kubernetes that are being added every single day. So things like identity, RBAC, which was added, not like lately, but like pretty fairly recent, and Ingress revamp, right? How do you control API machinery, and how do you make sure there's a lot of work required around networking. Encryption is another one. So things that we are quite familiar with in the enterprise world, right? But because the whole community is adding continuously to add features, those things are slowly coming, but everyone is looking at them because all these enterprise companies are looking at Kubernetes and containers to actually run their stuff in production with zero downtime. So we're at that point where everything is about how do we make this thing better. So definitely get on it if not already. There's a lot more stuff we can do, and because this is open source, everyone can basically like go and look at the code, and there are always issues that you can grab and start digging into the code and contribute.
How difficult or time consuming is it for me to get a Kubernetes cluster up and running?
If you're using a managed service, Azure has AKS, and Google has GKE, and Amazon has its own. So if you're using some managed form of Kubernetes, is actually pretty fairly easy. In Azure, it's literally like one command through the AZ CLI. All you need to do is just basically tell it, here's my credential, and here's a location, and here's how many nodes I want in my cluster. And then bam, it just comes up in like few minutes, really. And then, but I think, if you're living on the edge, where you want to like play with the latest features, and be able to get into all the master nodes, then that's where ACS Engine can be actually kind of fun. Because like I said earlier, ACS Engine is open source, and it's the backbone of AKS. And because it's open source, you can pretty much like change stuff as you see fit. But also it's leading in terms of features and the getting the latest of Kubernetes. For example, I think we have 110.1 now, even though Kubernetes 110 just came out like a couple weeks ago. So we're always living on the edge.
Yeah, and it's literally like AZ, AKS, create, and then you need like a resource group name, a cluster name, and then the number of nodes like you mentioned. And I put that line into a tweet at one point just to show people like this is the only command you have to run. I actually put in there a second command line, which was to actually create the resource group. But I found it super easy. So I really like the maturity of that. Like I don't have to. I tried to install Kubernetes one time and I was not successful. But with the command line, I was able to do it quite easily. So that was super awesome to see.
Yeah.
Yeah. So I wanted to ask this is like a sort of a broad question, but like what is Kubernetes like really great at? What are some like really great scenarios?
So let's take the, AZ CLI one liner that you just mentioned.
Yep.
Once you get the once you get the Kubernetes cluster up and running, you then you run another command to get the config, the kube config from the cluster, and then you just basically start pushing deploying applications to that Kubernetes cluster with the kubectl CLI. So kubectl is the Kubernetes CLI that you have to run locally to be able to talk to the cluster. So for example, kubectl get node, and then you can inspect the node. There's a lot of documentations on the kubectl CLI. But things you can do are basically like the basic stuff that an operator would do is like, oh, what's the state of my cluster? How many nodes I have? What type of node I have? And then how many applications are I running in the cluster? Stuff like that. And then most importantly for developers is you will be able to then deploy your applications by telling Kubernetes, hey, use this. In Kubernetes, there's this YAML configuration that you can create to describe what type of deployment you want. Do you want to run an application with ABC containers? Do you want to create a service for this particular application? And as we mentioned earlier, that you can also like do ingress controllers or define like, hey, I want to create a public IP for the service that I'm creating. So lots and lots and lots of features just by doing kubectl. The other one that I want to mention is there's also a project called Helm, HELM, which is basically application packager for Kubernetes. So everything that I just mentioned that you can do via kubectl, you can basically create a Helm package that includes all of the stuff in what we call a Helm chart. So then you can use Helm CLI to say Helm install, Rita's application, and it basically does the deployment for you. It also manages application releases, and you can also, delete the entire application when you want to, like, say, delete it from the cluster. And again, it's just another layer on top of Kubernetes to make it a little easier for developers.
Okay. Yeah, we actually, so for the MS Dev Show, I created a Docker config, and actually that's how our site gets deployed. It gets built. We've actually talked about that on the show before, but I wanted to get the MS Dev Show also running in Kubernetes, and I did that. And then I created a YAML configuration that defines a load balancer service, and then it also creates a deployment which ends up pulling that Docker image that is our website. So it's pretty cool because you can, with a simple command line, then you can tell if you have a Kubernetes cluster, you can basically say, hey, I want to run the MS Dev Show, and boom, you will have that running with multiple replicas as well. So you'll have high availability, which is pretty cool.
Yeah.
Yep.
Yeah. Is there anything that Kubernetes might not be a great fit for?
I hate to say this, but like I mean this is personal experience, but depends who you ask. But I honestly haven't seen a lot of Windows type of workload on Kubernetes yet, and I feel like in general there is not as much support on the Windows side. And this is probably one of the reasons why when I work with customers, I usually say, if they're like a traditional Microsoft .NET shop, I'm like, you should probably look into Service Fabric. Just because, Service Fabric was created to be really, really good at running .NET workloads. So again, I don't have too much experience on this stuff, but then this is kind of one area where I feel like Kubernetes is not really made or created for, and because of that, you want to have that conversation with the customer to make sure, depending on their need, they should use the right tool for it.
Yeah, that makes sense. Plus, the Linux support obviously has years of it production workloads versus Windows. So I'm sure Windows will catch up, and then we'll start to see, the enterprise customers tend to move a little bit slower too. So I suspect, like, if you're working with these partners that are, using Kubernetes today, they're probably using Linux. It's probably just a little bit different customer profile, and we'll start to see more Kubernetes on Windows, like you said, or, like you said, they could be using Service Fabric. That makes a lot of sense.
Right.
So you mentioned this earlier, and I just wanted to kind of dive into this, but you mentioned something about doing placement. So, does this work the way that I think? I mean, can I define like, hey, I have this one service and it requires tons of memory, and this other one requires tons of CPU. Can I have Kubernetes sort of optimize which node that gets placed on?
So there are things that Kubernetes does natively, but there's also things that you can do yourself to make sure the application runs in the node that you want them to. And the way to do that is with labels, or you can taint the node, and you can. But the point is there are things that we can define, right? When in your deployment YAML to make sure that this is actually running on the node with the resources with enough resource that you want to run on. But in general, like, if you don't do that, in general, it's smart enough to know, hey, if you need one GPU and all these other nodes don't have it, there's only one machine with that one GPU. It knows how to find it.
Okay, that's pretty cool. Yeah, and it uses, like you mentioned, labels, and I know we didn't really dive into that, but I mean, you could say, like, if you labeled one machine as red, and then you had a service, you can define a label on that Kubernetes service, right? And then it will, if it has the same red label, it will put it on the red machine, right? Am I understanding that right?
Yeah. And one of the things I can think of is like, say, like in your one of the things is like, say, availability zones, right? Is you can probably decide, like, depending on the availability zone, you'd probably, let's say you're running multiple instances, you probably don't want them to all run in the same availability zone, right?
Right. Yeah, that makes a lot of sense.
Yeah, I've been doing a fair amount of work lately with Docker containers on IoT devices. Can Kubernetes scale down to small devices like this?
On a Raspberry Pi, yes.
Awesome.
Okay.
How does that work?
If you're running, Raspbian, you can just pull down Docker, and then you can just run Docker like you run it on your, beefier machines. It's really no different. Where it is probably a little bit different is like, whatever Raspbian supports, which, sometimes it's not everything, right? So.
Yeah, and well, we should link in the show notes too. There was a blog post by Scott Hanselman. He has a cluster, I think, of 5 Raspberry Pis, and they're all powered off of USB. And he installed Kubernetes on that. And that's kind of a neat way to have like a mini Kubernetes cluster if you want to play around with. I mean, I think the easiest is to just do it in Azure. But if you actually wanted a physical cluster of machines, you could do that. And I don't know like what kind of performance he's seeing on that or whatever, but still it's kind of cool. If a node goes down, I don't think he was using redundant power supplies or anything, but it's still pretty neat to be able to throw a Kubernetes cluster of 5 machines like into your backpack for testing.
Yeah. That was definitely a good demonstration of because Raspberry Pi is actually pretty good for a lot of workloads actually. So it was definitely a good demonstration of like, like I said, if you can run Docker, you can run Kubernetes, right? All you need is just network connectivity between all the Pis. And I actually wrote this like blog post about how to set up your own VPN server on Raspberry Pi, because so that who wants like to have a dedicated machine just for VPN, right?
Yeah.
Especially if you're at home, like you just need something tiny, and so it's actually pretty perfect.
Okay, I'll have to check that out because I have something running my router right now, but it was kind of a pain. I'd rather just use a Raspberry Pi. Yeah, that's a great idea. And so you have that running in a container, or is it just running on the Pi itself?
I actually did both ways, just to see. So I originally created one just running on the Pi by itself, and then a lot of people commented on it, and then I was like, oh, this like I should just create a container for this.
Yeah,
so
exactly.
I did that. Okay. And then I did a second post for it.
Okay, cool. And then, in addition to Kubernetes, like, are there other container orchestrators that might have some feature benefits over Kubernetes? I know you mentioned Service Fabric, and there's some obvious comparisons to be made there. But like, are there people that should be using something else completely?
Yes. So it depends on your need, right? Like, so as I mentioned earlier, Kubernetes is an orchestrator, it facilitates the request, right? And monitors the health of your cluster and make sure everything runs the way you want it to run. But at the end of the day, it's not a platform, right? So there are times, like especially for the more bigger companies, like they're looking for platforms, meaning they're looking for a technology that not just do the facilitation, monitoring and resource allocation, but also, hey, I want this really blown out platform that can help my developers. And all the developer has to worry about is like, here's my code, right? And that's where, so OpenShift is basically a platform, and OpenShift is Kubernetes platform. It is Kubernetes underneath, but it has like a lot of the platform features, like CI/CD, like rollbacks. I think there's also like routes. So RBAC, before Kubernetes had it, OpenShift actually started RBAC. But now that work has been contributed back to Kubernetes. So now everybody in Kubernetes can enjoy RBAC because we all need it. Mm-hmm. So that's one. The other one is Cloud Foundry. And there's a lot of communities, especially big Java shops. They love Cloud Foundry. And Cloud Foundry is, again, a platform. And it's really good at running like Spring Boot apps or Java applications. And again, that's a platform. It also supports Docker containers. I think it's playing, like, I think they're trying to do more Kubernetes like integration there. So definitely looking forward to see more developments there. And then there, but to your point, like if you're a traditional .NET shop, Service Fabric is really good at that. Okay, and again, that's a platform, right?
Yeah, that makes sense.
So is there anything that we missed or forgot to mention that you'd like to bring up about Kubernetes?
There's lots and lots of areas that need to be better in Kubernetes. So if you are someone who wants to get into this, but also really want to like contribute to open source, it's definitely a really good project because there are just so many things you can work on, whether that's core Kubernetes features, or just like things that touch Kubernetes. So for example, logging, monitoring, encryption, identity. So those are things that you can do sort of like not part of Kubernetes, but those are important parts of Kubernetes that may not necessarily like live as core Kubernetes. And Kubernetes is built in such a way that all the APIs are actually highly extendable. So if you want to write your own custom definitions, you can do that, and then having define a certain way to run your own application or your own solutions on top of Kubernetes and have other people reference it. And that's something called custom resource definition. So for example, like a lot of the database systems, so like MySQL or Couchbase, what they have done is they've extended Kubernetes by having custom resource definitions to create custom APIs for their applications so that when they deploy their solution, all they need to reference is that custom API. So those are definitely very exciting areas. So if you're interested, those are definitely places to play around.
Very cool. And then how does somebody actually get started with Kubernetes? Like, is there a good resource for learning about this that you recommend?
I think there's definitely a lot and lots of resources off of the official Kubernetes.io website. But I would say most of the docs are more like there's architectural design, but more things are like conceptual, right? Conceptually, this is how it works, and here are the commands to run. But if you want to like kind of look at new things, that's where you can go to the Kubernetes GitHub org and look for like docs and design docs to look at how the communities are making some of the design choices. Another thing you can get yourself involved is joining the Kubernetes Slack org. And then within that Slack org, there's a lot of different SIGs, so special interest groups. Mm-hmm. So for example, there's SIGs for identity, there's SIGs for networking, and there's one for Azure. There's one for apps, right? So if you're really passionate about a sub area in Kubernetes, you can join those SIGs, and then there are like weekly phone calls, meetings that you can go to. It's the entire community is really, really open. And then also check out docs on Microsoft.com. Under AKS, there's actually a lot of like get started documentations.
Okay, very cool, very cool. Okay, Carl, what do you have for the dev tip of the week?
For the dev tip of the week this week, hold on, I closed my window on accident. I have
automatic window reopener.
no. The .NET source code browser. It's really awesome. Once again, when Microsoft puts out code online, but the .NET Core source code is available at source.dot.net. So it's source.dot.net.
We'll have a link in the show notes.
we'll have a link.
Yeah.
But it's really cool. I mean, you can see like what int32 is, or like the cryptography APIs are. You can see all of the code and all of the comments that go in there. Mm-hmm. I've used this tons of times when something's not working quite as I think it should. I can pop it open and be like, oh, that's why it's working like that. Or sometimes I'll be browsing the code and be like, that's a really good pattern they're using, or some, I'm able to improve my coding style based upon what I see there. So just remember that you can go to source.net. Fun to say too.
I don't think that's helping, Carl.
and just check out, see how it's built. It's pretty cool. And just a little shout out to Neil Turner. He had posted this on Twitter, and I got it from him.
Cool. Okay, Rita, there's a game that we play on the show. I have this kids game called Would You Rather. So I'm going to ask you a question here. Would you rather be friends with a witch or a giant?
Giant.
Yeah, but what's your reasoning there?
I don't know. It just feels like then I can, I don't know, like see things really far away.
Yeah, but don't witches have powers? That seems like
but they can also be evil, right?
Yeah, but you're friends with them, so I don't know. I'm not trying to sway your opinion. I think my answer would be different. The giant would be cool though too. I mean, there's not many of those around, so. Okay, Carl, if you were shrunk to the size of a thimble, would you rather have to run across the playing area of a pinball machine during a game or across an air hockey table during a game?
I would say pinball, just because you have no footing on air hockey and those things go a lot faster.
Yeah. Well, and in a pinball machine, like I feel like it's
like Indiana Jones. Yeah,
it's like you could like parkour your way across the table. Like, and the ball does move much slower, to your point. So that's a really good point. Okay, Rita, where can people find you?
I'm on Twitter. My handle is Rita Zhang.
Okay.
And you can also check me out on my blog post, which is ritazh.com.
Okay.
And my GitHub handle is RitaZH.
Okay, very cool. And where can people find you, Carl?
You can find me on Twitter at Carl Schweitzer.
And you can find me on Twitter at twitter.com/ytechie. So Rita, thank you so much for coming on here and talking to us about containers and Docker and orchestration and Kubernetes and all the things related to that.
Awesome. It's been great being here.